Okay, today we are going to be talking about absolute value functions, section 4-4. We're going to be using our graphing calculators and seeing how to find some minimum values using those. So you will need to have that. So you need to pause this if you don't have it and go get your graphing calculator. Okay? So here we go. Absolute value functions have the form f of x equals absolute value of x. So let's take a look at an example. Y, which could also be f of x, remember that's the same thing, equals the absolute value of 2x minus 1. So we've got some questions about it. We want to sketch the graph. So let's sketch the graph by using our calculator. So in Y1, let's type in absolute value. Now that is math num. And there it is. And then 2x minus 1. If you have an older operating system, then yours says ABS. Now we're going to go to Zoom 6. All right. And then from there, I want the table of values. So second graph. And I'm looking for like a rainbow effect. And there it is. So you can see like the 5 and the 5, the 3 and the 3, the 1 and the 1. Now, unfortunately, the minimum point's not in there because it has two repeating y coordinates there. The minimum would be the one standalone. It would not have anything repeating. So we need to be able to find the minimum. To find the minimum, we're going to go to second trace number 3, which is minimum. Maybe that works better. And then it says left bound. So you have to figure out where the cursor is. And you need to put it to the left of the minimum point because it says left bound question mark and then press enter. And then it says right bound question mark. So you need to now move the cursor to the right of that minimum and hit enter. And then it says guess. And I usually just kind of put it back on the minimum. And it says enter. Now it's going to come up with, maybe your decimal might be different than mine, but you have to be smarter than your calculator. I am assuming that this is a minimum value. You can see that it's on the x-axis, so I'm assuming that this minimum point is 0.5, 0. This 6.3735e negative 7 is scientific notation for 6.3735 times 10 to the negative 7, which is like 0.000, like 5 zeros, point with 5 zeros and a 6. And so to test this for sure, I'm going to go to second trace value, which is choice 1, and I'm going to enter in 0.5, and it says y is equal to 0. So that verifies that that is indeed the minimum. The programming is a little bit crazy, so that's why it comes out with the decimals. All right, so I have enough to go back here with. So, first of all, I did y1 equals absolute value of 2x minus 1, or some of you might have y1 equals ABS parentheses 2x minus 1. To get that symbol or the ABS, you do math num ABS. Okay? So math num ABS. All right. So I'm going to set up a table of values now. Remember, we had that rainbow kind of effect, so -2, 5, -1, 3, 0, 1. Then there was kind of like nothing in between these because the x-coordinates are all integers. But hopefully you see that rainbow that I'm talking about here. But we need to put that minimum value right in the middle there. And we found it by doing that second trace minimum. So it was 0.50. So to find the minimum, we did second trace minimum, which was choice 3. And then we went to the left of the min, and we hit enter. Then we went to the right of the min, and we hit enter. Then we saw guess, question mark, and we went on the min, and we hit enter. Now when we did that, came out with some weird number like 0.500 with a whole bunch of, other things, and then like 1.1541e -6. Well, if you just go to second trace value, and you type in 0.5 for x and hit enter, it says that y is equal to 0. So that verifies that our minimum was 0.5, 0. So let's sketch our graph. So -2, 1, 2, 3, 4, 5. -1, 3, 0, 1, 0.50, 1, 1, 2, 3, and 3, 5. So it should look like a V. And if yours has got a bottom on it that's like a horizontal piece, then you have not found the minimum point. Is this a function? Does it pass a vertical line test? Yes. However, it does not pass the horizontal line test. You can look that you've got repeating y coordinates. So is it 1 to 1? No. Is it onto? No. Absolute value and parabolas are never onto. Just the oblique lines and the square root graphs. The domain means what are the possible values that we could enter in for x? Everything, anything. There is no limit. We do not have a radical to worry about negatives under, and we do not have a fraction. So x is all reals. The range, however, is what are all your possible y coordinates? Well, if you look at your table of values, the smallest y coordinate is the y coordinate of the minimum. So y, if you look at all the rest of them, they're greater than or equal to 0. And then find the coordinates of the ordered pair with the smallest value of y. Well, that's asking for the minimum, which was 0.5, 0. So a function, again, is 1 to 1 if no two ordered pairs have the same second element, so no y values repeat. So this is not 1 to 1. And every absolute value function is not onto or 1 to 1. Okay, so more practice here sketching the graph. Sketch the graph of each function. So let's go back through our steps again. So I'm going to go to my calculator again and go into y equals, and in there I'm going to enter 4 on top of the 2, and on top of the 1 I'm going to do 6. And graph this time. And again, you see the minimum. Now I'm going to go to my table, second graph, and there you can already see the rainbow. 10, 6, 2, 2, 6, 10. But it is again not showing the minimum. So you need to find it. So second trace, number 3, which is the minimum. Get that cursor, use this left arrow. Just get a little bit to the left and hit enter. Then a little to the right of that minimum and hit enter. And for the guess, put the cursor on the minimum and hit enter. And again, we get this crazy 1.4999, 7.2253. I believe that's really 1.5 comma 0. So to check it, I'm going to go second trace, number 1 value, and I'm going to enter in 1.5. And hit enter. And it tells me when x is 1.5, y is 0. So I have a table and I also have a minimum. So for my table, I'm going to go over here. And it was negative 1, 10, 0, 6, 1, 2. Leave a space for the minimum. 2, 2. 3, 6, and 4, 10. You see that rainbow effect. Cannot have the bottoming out like this, though. There is a minimum, and we found the minimum to be 1.5, comma 0. So that is the value that I'm entering here for the minimum, and now I'm able to graph it. So 1.50, negative 1, 10, 0, 1, 2, 3, 4, 5, 6, 1, 2, 2, 2, 3, 6, and 4, 10. It's just a steeper V. Okay, so there's y equals absolute value of 4x minus 6. So I just went into the y1 and changed that around a little bit. Remember we did, to find that minimum, we did second trace min. We went to the left of the min and we hit enter using the cursor. Then we went to the right of the min and we hit enter. And then we went, and then it says guess, question mark. And we put it on the min and we hit enter. These are just quotes, by the way, which mean the same, of min. And when the guess came up, 1.499, and then it was like 6.0276 e negative 6, that really just meant 1.5 comma. This is like 6.0276 times 10 to the negative 6, which is 0.000051250 is a 60276. But when you do second trace value and you think your x coordinate for the min is 1.5 and then you hit enter, yes, it comes out with y is equal to 0. Okay, so back to our questions now. It says state the range of each, so that's really part B. And the range is what are your possible y's? Well, if you look in your table of values, your smallest y coordinate is the minimum y coordinate. So your range and all your y coordinates are greater than or equal to 0. Your domain is all reals. Your x's are all reals. It's no limit to the x value you can plug in. So it's all reals. There's no radicals to worry about. There's no fractions to worry about. And there we go. And find the coordinates of the ordered pair with the smallest value for each function. Actually, that was the minimum, which is 1.5 comma 0. All right, next one. All right, so let's go back and enter that one in. Okay, so back to y equals. So this one I'm going to enter 2 minus, it didn't take my 2. 2 minus x divided by 4 plus 3. And if we take a look at the graph, okay, so it's kind of hard to see the min. So I'm going to go to the window. We haven't done this before. And I'm going to look, I need to see a little bit more of the right side of the graph, which would affect the x max. So I'm going to change that to 20. And then I'm going to hit graph. Everything else is fine. And now it kind of like adjusted the screen to the right, so now I can see everything. If I go to my table, I need to kind of see that rainbow, so I'm going to go down here because it just seems to be decreasing. Aha, so there it is. There it starts to decrease to 3 and then increase. So now the minimum is showing up in the table because the x-coordinate is an integer. So you cannot assume that, your x table is always going to have integers in it. So that's why we had to do a little bit extra to find the minimum. Let's double check that min. Second, trace, choice 3. The left bound is good, so I'm going to hit enter. Move it over to the right. Enter. Then I'm going to put it on it and hit enter. And again, that minimum comes up as 7.99, y equals 3. Yours might say something a little different, but verifying second trace value, x is, I think it's 8, 3, and it is. Okay, so now I'm ready to go back and graph it. So let me just write a couple things down here. We did y1 equals that absolute value of 2 minus, it looked like this, plus 3, and we did graph. And then I went to the window and I changed the x max because I wanted to see more of the right hand side. So I changed the x max to 20 and then I hit graph again. And then this time when I set up my table of values, it had the rainbow effect: 6 3.5, 7 3.25, 8 3 was the minimum, 9 3.25, and 10 was 3.5. So 1 2 3 4 5 6, 1 2 3.5. Oh, my orientation's off. I'm going to pause for a second here. Okay, we're back. 6 3.5, 7 3.25, and 8 3, and 9 3.25, and 10 3.5. So it's wider, absolute value, but still a V. The range is the y-coordinate of the minimum and larger. There is no y-coordinate less than 3, so its y is greater than or equal to 3. The domain is, again, all reals, no radicals to worry about, no fractions. The minimum was 8 comma 3, which answered C and B from the previous. And then the sketching was part A. All right, and so tonight on your homework, you're going to be dealing with doing some of this, graphing. So Make sure you've got your calculator with you, or actually tomorrow in class. So good luck.